Hi, hello everyone. So last time we did depth testing, and this time we're going to actually do the instance rendering. So where do you want to use instance rendering and what it is actually? Well, if you take a look at here, what we had last time, we had two pipelines. We had unlit pipeline and then unlit pipeline 2, right? We were actually assigning those. And when you want to use instance rendering, if you have some pipeline or material that's kind of same, but you just want to create another instance of it, for example. So in this case, we just want to actually have another instance to actually apply, how should I say it? So only thing that's going to be different is our transformation matrix. So maybe we should start with it and then you can figure it out. So to do instance rendering, first what we're going to need is actually to extend our buffer so that it can actually have multiple objects in it. So for now, we usually had, if I take a look at here, in our unlit render pipeline, for transform, we had constant buffer, but it can only store one matrix. So we're going to extend it to be actually so we're going to extend it in a way so that it's possible to store multiple matrices. And so here I'm going to use simple approach. I'm just going to say byte size, and then I'm going to assign it to nil. So here, if our byte size does not equal to nil, I'm going to do one thing, and the old implementation is going to say the same. So this way we're not going to break anything, right? So all of our constant buffers, which we already assigned, are going to be the same. But if we use this override, we're going to do something different. And here, it's actually going to be really simple. We're just going to make buffer, and length is going to be our byte size. You just have to put exclamation mark and exclamation mark to unwrap this, because this might be null. All right. The second step is we actually need to write our array data, right? Because here it's taking the size of t, so it can only save, for example, one entry of a matrix. So I'm not going to explain it real soon. Let's just type this out. So we have to say in out, and we're going to pass here an array of whatever the generic is. So it's kind of similar. We access it in a similar way. We say contents, and then we can say from. We're copying from our actually no, sorry, my bad, copy memory from our data. And what's going to be byte count? Well, we can still use memory layout, right, of t, that size, and then we can multiply by our data and then count. Right? All right, and the second step that I can do, I can modify this here method as well. So we can say here instance. So that's just going to be index. You can call it index as well. And I'm going to see here, say here advanced, and then we need memory layout. That size times instance. So what am I doing here with this, right? So let's try to visualize it here. So let's say that we have an array, and we have a t, and let's say that each of these t's is, right, let's say that's maybe 64 bytes, or better yet, it's 16 bytes. Anyway, it's not important. But whenever we want to advance here, right, we see here advanced, we're using this t and 10 times the instance. So t times, let's say instance is 0, is 0. That's 0. So we're looking at the start of the array. So when we're advancing by t, we just say that t is 16 bytes. So this is 16 bytes, right? So if we pass t size of t actually times 1, so it's going to be 16 times 1, so that's 16. So we're actually pointing here, right? Because this starts as 16, this starts at 32, this t, and then we go to n, right? So it's just advancing the memory and writing in this location. So we can write here, or we can write here n to some n, it doesn't matter. So that's all it does, and the byte count is always the size of t, which I mentioned is 16, but it might be 64 actually. It's not that important. Yeah, it's 64 because it's a matrix. But anyway, it's not super important. It's going to be determined by this memory layout size, so we don't have to worry about it. Let's go further then. So to actually pass that array to shader, here in our transform, it's not going to be a reference to a single transform. We're actually going to pass it as an array. So just make sure to change this modifier. And here, the same way that we had built in for vertex data, we're going to have built in for instance data. So here, I'm just going to say instance ID. And then here in transform, we're actually using that instance ID. So what's the difference here? Well, if you take a look at this vertex data, so we already know we have a triangle, so this is one vertex, second vertex, third vertex. But if we want to create another triangle, which is kind of same, it's just different instance, right? So you have this idea of pipeline, right? This is pipeline, then you have global buffers, so they're true for everything. But then you have this kind of idea of an instance, right? So this is instance 0, this is instance 1, right? Or so what that means is, and here we have v0, sorry, v1, v2, and then this is going to be v0, v1, and then v2. So that means that this data, so we might get past 0, 1, 2 here for the first 3 vertices, and then instance 0, 0, 0, right? And then for the second triangle, we're actually going to have 0, 1, 2, but 1, 1, 1 for the second instance, right? And then again, if we have a third instance of this, right, we're going to have 2, 2, 2. All right. I hope that's clear. And here it was just for the triangle data, but you get the idea. Okay, so we solved that. So in our unlit render pipeline, we can get rid of this transform. We're not going to have it anymore. We don't need it, and we're actually going to paste it here. So we can just say our transforms buffer is a constant buffer. So it still needs to be of t, actually not t, simply float 4 by 4. But then we're going to have to say instance, and that's of type int, and by default we're just going to say 1. We're always going to draw at least one instance. And then so here we just need to change the transforms buffer because it's transforms here. This should be quite alright. I mistyped something, that's quite alright. And here we can just say, we can just use another overload, which is instance count, and we can say instance. Actually, we can name this count. It's going to be clear what it means. Cool. So last step, just in our coordinator, we can get rid of this unlit pipeline too, and everything related to it, because we're not going to use it anymore. So just unlit pipeline 2. And here I'm going to clean this up as well. We're just going to have unlit pipeline. So here what I want to do is as follows. I just want to create a transform buffer and then some array of matrices. So I can say transforms buffer, subtype constant buffer, default 4 by 4, and I'm just going to assign it to nil because I have to. Then transforms, that's going to be an array of cd float 4 by 4, and it's of type array. So here we can say repeating. So we're going to create our 4 by 4 matrices, and then for count we can just say 100, for example. And then somewhere below, maybe, let's see, here, transforms. Let's just create a buffer quickly. Constant buffer, cd float 4 by 4. passing device. And now we're going to use actually that second overload that we created, if you remember. 4. So it's going to be the size of this, and then we had 100 instances here. So it might be actually can also pass here transforms count, and then we can just fill in data in our buffer. So first of all, we're just going to manipulate transforms a bit. So we're going to say I, and then we can say matrix.translate, and here what we're going to do is we're just going to create random matrices all around the place. So let's go 5. So x minus 5 to 5, same for y, and for z, since our z is going to from 0 to 1, we can just say 0 to 10, or maybe here our projection view goes to 5, so we can say to 5. We can modify that later. And then transforms buffer, we just need to write that array data to it, so we can say transforms. And finally we need to pass it in here, so we're going to say transforms, and number of instances, for example, is 100. If I run it, it doesn't work because I need to unwrap it. Okay, some errors which I need to fix. Here it's not comma. Let's try again. Transforms buffer. My bad. Transforms buffer. I forgot to clean up the pipeline. My bad. It happens. So you just have to fix those errors quickly. And it kind of works, but I'm just going to modify it a bit so that it's a bit clearer. So I'm just going to say from 5 to 10, and then I'm going to modify our projection view to actually go to 10 in far. So yeah, this looks better. This looks way better. So that's it kind of regarding the instance drawing. One thing that I haven't mentioned is you can also play with these values that we had in our transform buffer, right? So you could do essentially, I'm just going to copy this quickly. We can do this, and then here we're just going to create a matrix, and in our matrix we can just write it transforms buffer, right? So we can say right. So we created this overload that I mentioned. And for the instance, we can say I. So it was not right array, it was right. Alright, if I run it, yeah, bar. And if I run it, okay, these are changing. So that's how can you use it. It's a rather simple approach. So that's it for this video. This video was rather quick, but I actually wanted to do that so that we have just 2 pipelines. And the next time we're actually going to continue with the matrices, and we're going to do view matrix. So if you like this video, please like, subscribe, and until next time.